So we are going to work on a different type of thing now, which is, do I have a buffer? Because we can mix things together and get all kinds of reactions, but we may not have a buffer as a result of doing that. So one thing we can remember is that acids and bases react, and we get salt plus water. And I mean acids and bases, I mean not a conjugate acid-base pair. Completely unrelated acid and base react together. Now for a buffer, we need two things. Both parts of a conjugate acid-base pair. And it needs to be a weak conjugate acid-base pair. So we need both parts. If you only have one, which we're going to do in a later video, it doesn't work very well. So that's what we need to make a proper buffer work. So what types of things happen is we get questions where we'll say mix, A and B, and it may tell you the concentrations of A and B and the volumes, or it may just say these solutions and say, could this produce a buffer? So we're going to try to kind of address those various types of problems. So let's say, for example, that they tell you that they're going to mix HCl solution and sodium hydroxide solution, and we're going to see if that makes a buffer. So first of all, let's say they gave concentration, so let's just make some numbers up, 0.1, 0.2 molar, and let's let them react. They're not a conjugate acid-base pair, so we're going to let them react. We're going to make sodium chloride. There's my salt, AQ again. That's an A, by the way. My terrible handwriting. And there we go, liquid water. So let's go back and look at what they are, because that's going to tell us what kind of salt we have here. So what we have here, of course, is a strong acid. Remember, know your strong acids and bases. This is a strong base. So it turns out if you have a strong acid and a strong base, even if you actually mix them, it really doesn't matter what proportions you mix them in. This is a salt with two spectator ions. And these are strong. So this will never make a buffer. Doesn't matter how much you mix, what proportions you mix these two in, you can't make a functioning buffer out of that. Why? Because any conjugate pairs you might make, say HCl and Cl minus, it's made with spectator ions, and they are not going to start setting up an equilibrium reaction. They just go all the way to one end. So the HCl just becomes Cl minus, and the Cl breaks into Na plus and Cl minus, and they just sit there and don't really do anything. It doesn't work properly as a buffer. Now let's look at another option. One might be a fairly obvious one. So they might say, for example, that you're mixing HAC, and remember, AC is a common abbreviation for acetate. Okay, acetate ion. So this is acetic acid. I'm just telling you this because it's often used. So we can mix acetic acid and sodium hydroxide. Okay, that potentially could make a buffer. It depends on how we mix it. Now, if they tell you that we mix, we'll come back to that one. If they tell you we mix HAC and NaAC, well, this is a buffer. As long as we have reasonable amounts, which means similar-ish within a factor of 10 of each of these, it will be a buffer. We have both parts. Why? Because we've got HAC, that's a weak acid, and then we've got acetate, the conjugate base of that. So there's my pair. We needed a conjugate pair, weak conjugate pair. So if you mix these two things, you definitely have a buffer. Now the example up here, we are going to find that we could have this situation but it depends on how we mix them. So let's look at some possible permutations on that. So let's go back to the HA and acetic acid. Oh, sorry, it's acetic acid and sodium hydroxide. Let's say, for example, once again, this is 0.1 molar, just making up numbers, and this is 0.2 molar again. So let's identify them. Strong base, weak acid. Okay, this is looking promising. When you have an acid-base reaction to make a salt and one's weak and the other one isn't, that's promising. So now we make our salt. We have Na acetate, sodium acetate, and H2O. So that's my possibility. So it really depends on how much of these we start with. So what you're going to have to do is use volume to help you. Because remember, volume and molarity will give you the moles. And that's what you're going to need to answer the question. So let's say, for example, given the volumes and molarities and thus the moles that we have, you do your calculation. Let's say we have more moles of HAC than NaOH mixed. Let's think about what that will mean. This number of moles here to start with is bigger than this one, so this will be a limiting reagent. This will all go away. So what we'll end up with is no sodium hydroxide left. We'll have some acetic acid because we won't have used it up. There was more of it. And we're going to have some Na acetate. And that is just what we were talking about up here. This was saying, you know, go and take these actual specific things and mix them together. This is creating it in situ. So it's the same effect in the end. This will be a buffer. Okay, so if you've got more moles of the strong base than the weak acid, we can end up with a buffer. Now what about the other way around? Here's another one. What we have is less moles of HAC than NaOH. It's NaOH, there we go, mixed. Now what we're going to end up with is no HAC, because that will all have reacted. We're going to have some NaOH, which we know is going to break apart completely, and we're going to have some sodium acetate. Well, the problem with this is what are we going to really end up with? We're going to end up with a whole bunch of Na plus and acetate minus, but we're going to have no HAC to start with, no significant amounts of HAC to begin with. And remember, what you need to be a good buffer is to have both parts. And when I say both parts, I mean a reasonable amount. So if you're starting off with basically 0 of one of them, this is not a buffer. And you might say, well, what about the other possibility? Equal moles of HAC and NaOH. Well, then what you'll end up with is no HAC, no sodium hydroxide, only NaAC, and for a complementary reason to this example up here, this is also not a buffer. You need both bits, okay? So you need both parts. So that's parts. So that's why these two don't work. You don't have both parts. And the top one does, because you've got some of this and some of that. So once again, you need both parts to make the buffer. So look at what's being mixed. The only other possibility, and this is a little bit more complicated, is you could have, and I'm going to use another piece of paper for this, the only other possibility is we can work back the other way. And what we could have is sodium acetate solution. This is a little bit weirder, but you can kind of think it through. If you have sodium acetate solution, what you're going to have there is sodium ions and acetate, and it's going to have its equilibrium going on, right? So we're going to have acetate plus H2O Okay? That can be happening if we just have this solution of sodium acetate. We talked about this in the salt video. But what now if I go and add something to force this to go forwards? Not force it to go backwards, force it to go forwards. Well, the way I can do that is, remember, this is a base, right? So if I add a strong acid, say HCl, if I add a strong acid, what that's going to do is it's going to react with this base, and what we're going to make is HAC, and then we're going to have sodium chloride. So depending on the proportions mixed, if you have enough of this to make some of this become HAC, it's the same situation as we just did earlier. If I can convert some of this into HAC, then I will have acetate and acetic acid. So this also could be a buffer if the moles of strong acid are smaller than the moles of sodium acetate, the salt of the weak acid. So it's a rather weird idea. It's like reverse engineering your original acid, and you've already got the conjugate base. But it is a possibility. So explore what the reactions are and figure it out. And quite likely, if you've got concentrations and volumes, you're going to want to know how many moles of each you mix to start with. So that should be your starting point, is to calculate that.